So today we are going to discuss about problems on damped free vibration. Damped free vibration. So in this problem, a machine weighs 18 kg. So mass is equal to 18 kg. So that is this is a vibrating system. This has 18 kg supported on spring and dashpot. So this is a spring. This is a dashpot. The total stiffness of the spring is 12 Newton per millimeter. Stiffness K is equal to 12 Newton per millimeter. If you convert this into millimeter into meter, you will get 12 into 10 power 3 into 10 power 3 Newton per meter. And damping coefficient is 0.2. This damping coefficient is 0.2 Newton second per millimeter. This also convert into meter. If you convert this one into meter, 0.2 into 1000 Newton second per meter. And the system is initially at the rest and a velocity of 120 millimeter per second. 120 millimeter per second. So initially the system is initially at rest. That is, rest means it is displacement is zero. Displacement is zero. When t is equal to zero, initially, that is t is equal to 0, x is equal to 0. This is a first boundary condition. That's what initially at rest. And what is the velocity? Next boundary condition is initially, that is t is equal to 0, and the velocity is 120 millimeter per second it is given. So convert it to meter per second. So 10 power minus 3 meter per second. So this is a velocity. So these are all the two boundary conditions. Is important to mass. Determine the displacement and velocity. Displacement and velocity as a function of time. As a function of time that you got to find. And at 0.5 seconds, you got to find the displacement and velocity. There are two things you need to calculate. So for that, time is given, no? So you have to, we know the, for underdamped vibration, we know the equation. The x is equal to capital X into e power minus psi omega n t sin omega d t plus psi. So this is a general equation, the displacement equation here. So the vibration will be like this. Vibration will be like this. It will be slowly dying out. So here what is x? X is a, this is a x value. This is a maximum displacement. This is x. This is at any point of time. At any point of time, displacement is small x. So this x is a function of time. This is a constant. This x is a constant. That is a maximum value. Maximum value. This is a function of time. Anytime, if you give the time, you can calculate. So this is a equation. Now, here two conditions are given. One is in terms of x, another one in terms of velocity. So you differentiate it again. If you differentiate it with respect to time, you will get velocity. So dx by dt is equal to x is a constant. You keep it. Here there are two variables. This is one variable. This is another variable. You keep one as it is first, omega n t, and differentiate this. What is the differentiation of this? This is cos omega dt plus phi into omega t, right? Plus capital X into, now you keep this is constant. This is constant. That is sin omega dt plus phi, and differentiate this. Differentiate this. That is e power minus psi omega n t multiplied within bracket minus psi into omega n. So this is a differentiation. Now what you have to do? You apply the first boundary condition. Apply the first boundary condition. When t is equal to 0, x is equal to 0. In this equation, this is equation 1. This is equation 2. This is displacement equation. This is velocity equation. In the displacement equation, substitute t is equal to 0, x is equal to 0. If you substitute, so at t is equal to 0, this is 0. This is x is equal to 0. That is equal to, if you substitute in this equation, t is equal to 0, this will be 1. So x will be there, x into 1 into sine omega d, sine phi. So here t is equal to 0. So this term will be 0, sine phi, sine phi. So this will be the equation. So here x cannot be 0. X cannot be 0, right? Because in the curve, this is the value of x. If there is x is 0 means there is not a vibration. That is not a vibration. So x cannot be 0. X is not equal to 0. Not equal to 0. Then sine phi is equal to 0. Sine phi is equal to 0. If sine phi is equal to 0, what is the value of phi? Phi is equal to 0. So this is the first one. This is first one. Now you apply the second boundary condition. Apply the second boundary condition. So here, what is t is equal to 0 at velocity? What is velocity? Dx by dt is equal to 0. Dt is equal to 0. In this equation, if you substitute the boundary condition, you will get the value of omega d. You will get the value of omega d. The omega d will be 25.26. You can get this value. So already we calculated the value of psi, pi. So how we calculated the value of phi? By substituting the boundary condition in the displacement equation. Then you substituted the second boundary condition, that is velocity boundary condition, in the velocity equation. Velocity equation, and we calculated the omega d. What are the other things in the equation? We have to find the value of omega n. We have to find the value of omega n and psi. These two you have to calculate. How to calculate omega n? Omega n is equal to, that is k by m. K by m. What is k in the problem? It is given. This is the value of k. So that is equal to 12 into 10 power 3 divided by m. What is the value of m? 18 kg divided by 18. So this will give omega n. This will give omega n. What is the value of omega n? It is 25.85. 25.85 radians per second. And we need to calculate psi also. We need to calculate psi also. What is psi? C by cc. What is cc? We have an equation 2m omega n. What is the value of c? It is given in the problem. It is given in the problem. It is 0.2 into 10 power 3 divided by 2 into m is 18 kg into omega n. What is omega n? It is 25.85. 25.85. That will give the value of psi. Psi is equal to 0.215. This is the value of psi. Now what you have to do? You have to write displacement and velocity equation as a function of time. As a function of time, you have to use. You have to write. Then what is the equation? X is equal to capital X. Capital X into e power psi omega n t. E power psi omega n t. What is the e power? What is the value of psi? Psi is equal to 0.12. 0.215 psi into omega n. What is the value of omega n? 25.85 into t multiplied by sine omega d. What is the value of omega d? 25.26. 25.26 omega d into t plus psi. Psi is equal to 0. So this is the equation. So this is the equation. Now we got the equation in terms of time. Now we got the equation in terms of time. So this is the first one. Similarly, dx by dt also you have to write the equation. You have to substitute the value of psi, omega n, omega t, phi, all the values substitute. You will get a equation. You will get a equation. That is dx by dt is equal to, you will get a equation. So that is a general, that is a equation as a function of time. After that, you have to find the velocity at 0.5 seconds. 0.5 seconds. So in this equation, you substitute t is equal to 0.5. So you will get the what displacement. What is the value? It is 0.123 meters. That is a x value. Similarly, in the displacement equation, you substitute x is equal to 0.5 and find dx by dt. dx by dt, that is velocity. What is that? That is 7.39 meter per second. Meter per second. So this is a way you have to solve this problem. So now we are going to discuss about torsional vibration. Torsional vibration. So see, this is a shaft and this is a mass. This is a mass. The shaft is acting as a spring. This is mass. When it is vibrating torsionally, that is about the axis. About the axis, it is rotating. So in that case, how to find the equation for torsional vibration, natural frequency equation? Already we know the simple harmonic motion equation, that is d square x by dt square plus omega square into x equal to 0. This is a equation. So already we have derived equation for linear vibration and transverse vibration. Now for torsional vibration, so you have to write the equation. You have to write a equation. In case of torsion, here instead of mass we have to take I, mass moment of inertia. What is mass moment of inertia? That is equal to m k square. M k square. So generally in linear it is mass. Rotating, we take mass moment of inertia, equivalent term. Similarly, where there you take x, here what you will take theta, angular deformation. Similarly, there dx by dt, here d theta by dt. So if you rewrite the equation in case of torsion, what you will get? You will get d square theta by dt square. What is here? You will get m. Here you will get I instead of I into d square theta by dt square. What is the linear equation? That is m into d square x by dt square plus k into x equal to 0. K into x equal to 0. Here instead of mass you take I. D square x, here you take theta plus instead of stiffness. What is stiffness? K by x. Sorry, load by x is a stiffness. But here what is instead of load we have t. Instead of x, what you'll have? Theta. T by theta. T by theta. So that is taken as q. That is taken as q. So the equation is q into, instead of x, you take theta. That is equal to 0. If you rewrite this equation, you will get d square theta divided by dt square plus, if you divide this equation by I, you will get q by I into theta is equal to 0. So now you can compare this one and this one. Instead of omega, you take omega n, that is circular frequency. Omega n square is equal to q by I. Then what is omega n? That is root of q by I. Here what is q? Q is equal to t by theta, torque by theta. What is I? I is equal to mass moment of inertia. If you write in terms of Fn, that is 1 by 2 pi into root of q by I. The q can be replaced. How it can be replaced? Already in case of torsion, we have studied t by j is equal to tau by r is equal to c theta by L. If you take this term and this term, from this you can find t by theta. T, that is q is equal to t by theta. Na? So t by theta is equal to cj by L. So this equation also can be written as 1 by 2 pi into root of cj by L. You can write like this also. Like this or like this. Whatever form you can use. By using this, you will be able to find natural frequency of a undamped torsional vibration. Undamped torsional vibration. So this is a torsion equation. So from this, you will be able to find the natural frequency. Now, we are going to see one problem. Similar problem we have seen for transverse vibration as well as linear vibration. The same problem we are going to discuss for torsional vibration also. Torsional vibration also. This is a flywheel. This is a flywheel. Um, it is shafts are fixed at the ends. So this is diameter of the shaft is 50 millimeters. 50 millimeters. And the flywheel mass is 500 kg. 500 kg. The radius of gyration is 0.5. Modulus of rigidity is 80 giga-newton per meter square. So our objective is to find the natural frequency. Natural frequency. How to find the natural frequency? Now let us see. When you see this problem, here the mass is equal to 500 kg. 500 kg. Radius of gyration, k is equal to 0.5 meter. Radius of gyration of this mass. And the diameter of the shaft is 50 millimeter. 50 millimeter. That is 0.05 meters. 0.05 meters. And the modulus of rigidity of this shaft is G is equal to 80 giga-newton by meter square. Now, what is the equation? The equation for natural frequency Fn is equal to 1 by 2 pi into root of Q by I. This is the equation. What is Q? This is torsional stiffness. So here we have mass here. Both sides we have shaft. Here, whether this is parallel or series, that you have to see. So this shaft will have Q1. This shaft will have Q2. If it is parallel, you have to add. If it is series, you have to use 1 by Q1 plus 1 by Q2. That equivalent stiffness equation you have to use. Now, the angular, when the flywheel is oscillating or rotating or vibrating, the angular displacement of the shaft 1 will be equal to 2. So then both are parallel. Both are parallel. You know how to calculate the value of Q1. Q already we have discussed. What is Cj by L? So here L1 you can use. You can use L1. C is modulus of rigidity. J is polar moment of inertia. This is common for both the shaft. So you can take Cj by L1. What is C? C already it is given 80 giga-newton by meter square. So 80 into 10 power 9 you put. What is J? Polar moment of inertia. That is pi by 32 into 0.05 power 4 divided by L1. L1 is 0.9. L1 is equal to 0.9. Then 0.9 meters. So from this, you can find the value of Q1. What is the value? It is 56 into 10 power 3 Newton meter. Newton meter. Similarly, you find the value of Q2. That is Cj by L2. That is 80 into 10 power 9. The same value. Pi by 32 0.05 power 4 divided by L2. The value of L2 is 0.6 meters. So the value will be 84 into 10 power 3. Since both the shafts are parallel, Q is equal to Q1 plus Q2. If you add both, you will get 140 into 10 power 3 Newton meter. The unit is Newton meter. Now you substitute in this, you find the value of I, mk square. What is the value of m? M is equal to 500 kg. What is the value of k? It is 0.5 square. Then it is 125 kg meter square. Now the frequency Fn is equal to 1 by 2 pi into root of Q by I. So 1 by 2 pi root of, what is the Q? It is 140 into 10 power 3 divided by I is equal to 125. So that will give the natural frequency 5.32 hertz. 5.32 hertz. So this is a way you can solve this. In case, so the same problem, the same thing. A shaft having one mass. So you have to find the value of Q and I. You have to find, you substitute, you can find the natural frequency of this. In the previous problem, it was vertical, it is horizontal. That's all. So here, this is known as node. Node means no deflection. At the support, there will not be any deflection. Here, the deflection will be maximum. Deflection will be maximum. So now, you see a shaft, it has a mass at one end, another mass at another end. A shaft has two ends. Once end we have a mass A, another end we have a mass B. It is subjected to rotation, torsional vibration. So in that case, so this will oscillate with some frequency. This will oscillate with the frequency. In such a case, the node will be somewhere here, somewhere here. We don't know the position. We don't know the position. Let us take the total distance is L. This may be LA. This is LB. So in such a case, this mass will have a moment of inertia. Let us take IA. Let us take IA. This will have IB. This will have IB. Similarly, if this is a node, this is a node. Here there is no angular deformation. Here it is changing like this. Here it is changing like this. So from the node, the distance is LA. From this node, right side is LB. Right side is LB. In such a case, the frequency of this one, the frequency of this one, and the frequency of this one, both are same. Both are same. So now you have to write the equation for frequency of the mass A and mass B. So this is the equation for mass A. This is the equation for mass A. Actually, Q by I. That can be replaced by Cj by L into I, because this is Q. This is Q. That's what we are using this equation. So here C and J are same for C and J are constant for both the mass. That is same shaft. So C and J are common. Only LA and IA are different. Similarly, for natural frequency of NB, that is Cj by LB IB. So in this problem, if two masses are connected at two ends and vibrating, the natural frequency of the mass A will be equal to natural frequency of the mass B. Natural frequency will be same, such that it will be vibrating. So if you compare this one and this one, you will get equation like this. You will get equation like this. That is moment of inertia of the mass into LA. LA is what? This distance. From the node, the mass A distance. That is equal to LB IB. LB IB. IA LA is equal to LB IB. So this can be used for solving this problem. This is when there are two masses. But here in this problem, the shaft is a uniform diameter shaft. Uniform diameter shaft. Sometimes the shaft will be ununiform. The shaft will be non-uniform. Suppose if we have a shaft like this, here there are shaft D1, D2, D3. There are three different shafts. In such a case, you have to make a shaft like this, equivalent shaft. This is called equivalent shaft. You have to make like this. What is meant by equivalent shaft? That is, this diameter need not be equal to this diameter. But when it is subject to the torque, it will be, say, all together, it is deformed by theta. If this shaft also, for the same torque, if the deformation is theta, angular deformation is theta, then these two are torsionally equivalent. Torsionally equivalent, because when two masses are given and different diameter shafts are given, this problem cannot be solved. It is difficult, but with the same diameter. So instead of this shaft, we have to convert some equivalent shaft which is having uniform diameter, but for applied torque, the angular deformation of this shaft and this three shaft must be equal. Okay. So now what I am doing is, this is the theta of equivalent shaft. How to find the theta? We know T by J is equal to C theta by L. Here what is theta? Theta is equal to TL by C into J. C into J. This is theta. So now what we are doing is, we are finding the value of theta for equivalent shaft. That is TL by CJ. Similarly, we are finding theta for shaft 1. This value. Shaft 2. this value. Shaft 3, this value. All together, adding these three will be equal to this one. This is the meaning. Okay. That is, angular deflection of the equivalent shaft is equal to angular deflection of the sum of these three shafts. Then this shaft is equivalent to this shaft. This shaft is equivalent to these shafts, right? So because to solve the problem easily, we are converting like this. So you got to find the equivalent shaft. Now, by substituting the value of J, all other things, you substitute like this. So finally, you will get a equation like this. Finally, you will get a equation like this. The whole power. You will get a equation like this. So the equation is, what is that equation? L is equal to L1 plus L2 into D1 by D1 power 4, D1 by D2 power 4 plus L3 into D1 by D3 power 4. So this is a equation. See, this is a equation. What we are doing here? So we are doing. So this is the equation. See here, what we did is, this shaft diameter is equal to D1, we are assuming. Any diameter you can assume. But in this case, the first shaft diameter D1, the same is assumed here. So, if you take this length here, if you divide this into 3, divide into 3, so this shaft diameter and this are same. So this length will be same as this length. After that, here we are taking D. So that's what here we are taking L1. Now we are converting this one into this one into this. If you want to convert this one to here, the length will be different, diameter will be different. Diameter is changing, length also will be changing. So so for this we are using this portion. L2 into, we are converting into D1 diameter. D2 we are converting into D1. Then the corresponding length will be this. Similarly, the third one, you can use this part. So in the reverse also you can do. We are going to do reverse also, that you will see later. So now we have a problem. Say a shaft of 1.5 meter long. So the total distance is 1.5 meter long. It has different diameters. This is 95. This is 60. This is 50. Length is 0.6, 0.5, 0.4. So these are all the dimensions. And shaft carries 2 flywheels at 2 ends. One is 900. So this mass is 900. Mass M1, MA, we can say MA is equal to 900 kg. 900 kg. And radius of gyration is 0.85. 0.85. Right? And another mass is 700 kg. This mass is 700 kg. And the radius of gyration is 0.5. Radius of gyration is, that is K is equal to 0.5. This is MB. This is K. KA, this is KB. So if you want to find the IA, IB, what you have to do? IA is equal to MA square. MA into KA square. Similarly, if you want to find the value of IB, MB square plus MB KB square. Mass into MK square. So now that you can calculate. So what you have to do is determine the location of the node. And natural frequency. These are the 2 things you have to find. G value is given. Where the node will be. So in this problem, node will be somewhere here. Where the location, that you have to find. So to find that, by different diameter, this problem cannot be solved. So you have to convert it into like this. So here, the equivalent shaft diameter, you are taking the same 95 you are taking here also. Same 95 we are taking. So this diameter is also converted into 95 millimeters. But similarly, correspondingly, the length will be changing. Here the same, since same diameter, this 0.6 no problem. Up to this is 0.6 and this is 95 because same diameter, same length. But here we are changing the diameter. Here it is 60. Here we are taking 95. Here 50. Here we are taking 95. So length also will change correspondingly. So how to calculate the total length? Total length L is equal to L1. You can take as it is. L1 you can take as it is 0.6. L1 plus L2 into, we are converting into D1. Yeah? D1 divided by D2 the whole power 4 plus L3 into D1 divided by D3. We are converting D3 into D2. So you have to put like this. When you substitute in this equation, L1 is equal to how much? 0.6. 0.6 meters. What is L2? L2 is 0.5 and D1. D1 is equal to 95. 95 divided by 60. The whole power 4 plus L3 is 0.4. 0.4 into 95 divided by 50. Whole power 4. So this will give the total, this length 8.95 meter. It is 8.95 meters. So the original length is 0.6 plus 0.4 plus 0.5, 1.5. But here it is coming 8.95 meters. This equivalent shaft. All are having 95 millimeter diameter. All are, but here in the original shaft, it is 95, 60, 50. So when diameter changes, length also is changing. So this is a, but what is a, what, both the case theta is same. Both the case theta is same. In that sense, it is calculated. So now what you have to do? So node may be somewhere here. So here already this is LA, this is LB. This is LA, this is LB. Already we have equation. Already we have equation. LA, IA, LA. IA, LA is equal to IB, LB. Because vibration of this is equal to vibration of this. If you keep this, you will get an equation like this. Here what is IA? We know. What is IA? IA is equal to mass is 900. 900 into mk square, 0.85 square into LA. That is equal to IB. That is 700 into 0.5 square into LB. LB you can return like this. So total distance is 8.95. Total distance is 8.95. So the LB can be written as, LB can be written as total distance minus LA. You can write like this. That is 8.95. This is only equivalent shaft length only you have to put. Because first you solve using equivalent shaft, then we can calculate using this. Divided by LA. So now you can calculate the value of LA. LA is equal to 2.2 meters. LA is equal to 2.2 meters. This is in equivalent shaft. In this shaft, not in the original shaft. Original shaft length is not 2.2. That you have to find. That you have to find. In the equivalent shaft, it is 2.2. Then what is the length in original shaft? We can calculate. How to calculate? In the LA, maybe somewhere here. Assume that it is somewhere here. So for the original shaft and equivalent shaft, up to this distance, diameter are same. Up to this distance, diameter are same. So the same distance will be there. So the remaining distance only. What is the remaining distance? This distance. This will be, how much this will be? This will be 2.2 minus 0.6. So that you have to convert into original length. So how to convert this one? L1 will be as it is. Why as it is? Because the L1 diameter and radius are same as this. Same as this. As far as L2 is concerned. As far as L2 is concerned, this diameter and this diameter are not same. So we know this length. Already we have calculated. This you got to convert into original length. For that, what you have to do? Just reverse of this. Just reverse of this. That is 2.2 minus 0.6. What distance? This distance. So what is the distance here? If you want to convert, what you have to do? Here, d2 by d1, the whole power 4. If you put, you can find that value. What is the value it is? It is 0.855 meter. 0.855 meter. So what is this distance? What is this distance? This is node in the equivalent shaft. The same distance in the actual shaft. Original shaft is this. This is equivalent shaft. The same distance we calculated. It may be somewhere here, somewhere here, right? So now this we have calculated. Now what you have to do? You have to do the frequency. What is the equation to find the frequency? 1 by 2 pi into root of Cj by LAIA. LBIB, LAIA, both anyone you can put because already both are equal. So this is 1 by 2 pi into root of C modulus of rigidity. Already we have 80. So 80 into 10 power 9. And J is equal to pi by 32. Which diameter you have to put? You have to put equivalent shaft because we are dealing with equivalent shaft diameter. You put how much it is? 95 points. It is mm. So 0.095 power 4 divided by LA. LA is equal to how much? 2.2 into IA. IA is equal to m into k square. M into k square. M is equal to 900 into k square, 0.85 square. This is whole root. So from this you can find the natural frequency. How much it is? 3.37 hertz. 3.37 hertz. This is a way you have to solve this problem.